is the same thing. We are talking about the interval estimation of the difference of two population mean, but we know more information about the population. We have sigma x squared is equal to sigma y squared is equal to sigma squared. In this case, what kind of sample variance should we use? If it is only one sample or one population, we say we use xx squared to estimate sigma x squared, right? And if it is y, then we use xy squared to estimate sigma y squared. But now we know sigma x squared, sigma y squared is equal to sigma squared. In this case, we have to use, this is called pool variance. Okay, and we denote it by SP squared. SP squared is equal to nx plus ny minus 2 nx minus 1 sx squared plus ny minus 1 sy squared. So you may wonder why we use SP squared rather than xx squared or xy squared. The reason is, of course, we get this information. Another reason is SP squared would be the unbiased estimator of sigma squared. So let us try this. Okay? So we want to show SP squared is the unbiased estimator for sigma squared. So let us try. Because if it is an unbiased estimator for sigma squared, then expectation of SP squared should be equal to sigma squared, right? Okay? So then this is equal to expectation nx plus ny minus 2 nx minus 1 sx squared plus ny minus 1 xy squared. We simply plug in the formula here. Okay? Now, this one is a constant, right? So we can move this out. So nx plus ny minus 2, okay, we get it out. And then expectation. Here you have nx minus 1 xx squared plus ny minus 1 sy squared. Okay? Then we know that expectation of xx squared should be equal to sigma squared. Remember, we proved this before. Okay, we proved this before. So in this case, what we get this is equal to nx minus 1 sigma squared, right? Remember, we say sx squared is the unbiased estimator for sigma x squared, right? But now the sigma x squared is equal to sigma y squared is equal to sigma squared, right? Okay, and then here the same thing, right? Sigma sy squared, okay, sy squared is the unbiased estimator for sigma y squared. And what we get? We're going to get sigma squared there, okay? So what is this equal to? The denominator is nx plus ny minus 2. And the numerator will be nx minus 1 plus ny minus 1. So that's nx plus ny minus 2, right? So that will be equal to sigma squared. So that's the reason we use, okay, the SP squared, okay, SP squared to estimate sigma square. So in terms of the final interval, the confidence interval, what is that? That will be x bar minus y bar, right? Plus and minus. And in this case, it should be t, right? It should be t. Okay, nx plus ny minus 2, alpha over 2. And this will be nx minus 1 plus ny. Sorry. Let me check my notes to make sure that I get it right. Okay, right. Remember, when we say t distribution, right? Okay, we say it is x bar minus mu x divided by sx squared divided by n, right? Okay? Even though we say the degrees of freedom is nx plus ny minus 2, right? But here you have to use nx and ny, okay? Nx and ny. And certainly this will be the sp squared, okay? This is the difference. Okay? Okay, the next one, we're going to talk about something that the two populations are not independent, okay? Okay, so we are trying to figure out the confidence interval for the difference of two populations and when these two populations are not independent. Okay, we are doing the same thing. We are trying to figure out the interval estimation of the difference of two populations, but these two populations are not independent. Okay, there are some examples here. So let us say you are the producer of oranges, okay? Say oranges or apples, okay? Let us say apple. You are the producers for apples, okay? So when you pick the apples, okay, then you have to ship them to the market, right? So from the moment you pick the apples, and then when you ship them to the market, sometimes there will be a difference, okay? Because you know, there are some ingredients in the apple, right? And sometimes the apple gonna get hurt. Suppose it hits something, or it dropped to the ground, okay? Then it will hurt the apple, right? So the weight. So here we are talking about the weight of the apples. So from the moment you pick to the moment you ship them to the market, generally the weight will be different, okay? Because of the something going on in the shipping process, okay? So the difference may not be that much, but so let us say, what about pigs? So let us say you are the farmers and you raise pigs, or say you raise cows, okay? In this case, or chickens, right? So when you are ready to ship them, okay, when you are ready to ship them, of course, you're going to weigh them and to get down how much they weigh, right? But when you get to the market, generally there will be a difference, okay, because there's a lot of reason. So that's one of the phenomena that you see. So sometimes, okay, you are afraid that, say, the animals, the pigs, the cows, the chickens, whatever, they're going to lose weight, right? You will be afraid that they will lose weight because all these animals, they are paid by the weight, right? So how much per kilogram, right? $100 per kilogram, etc. So sometimes you heard the rumor. What's the rumor? They feed the animals with what? With water, right? To increase their weight. So anyway, there is such kind of phenomenon that you really care about the difference of the two populations, okay, the mean of the two populations. And you want to figure out how to deal with this kind of question. So let us say this is the weight, okay, before shipping to the market. And y is after, okay? The weight after shipping to the market. So you want to figure out what's the difference there. But you know, as a matter of fact, these are exactly the same thing, right? These two are exactly the same thing. So how to figure out the difference? So in this case, what we do is that we get a new variable. What's the new variable? The new variable is d. Okay? D means difference, okay? And what's the difference? Xi minus yi. Okay? So this is the difference. And so for this shipping of apples, and when it gets to the market, you weigh them again and try to figure out how much they weigh. So this is the weight before shipping. And this is the weight when it reached the market. Of course, this will be di, right? Because there are so many, right? So 1 to n in this case. Of course, what we are interested in is mu d, right? What we are really interested in is mu d. So the variable we have is d, okay? Because these two things, they are not independent. And so in this case, when we try to deal with them, there will be some difficulties. So that's the reason we use another variable that's d, okay? di is equal to xi minus yi. And so really, we are interested in this variable. And what's the mean? The mean will be mu d, and the variance will be sigma d squared. And so how to calculate them? As a matter of fact, it's just easy, right? So we have d bar, right, is equal to summation di divided by n. And what is this? This is summation xi minus yi, okay? And then, of course, we want to know x d squared, right? What is sd squared? That would be n minus 1, and this will be d minus d bar squared. So even though this is a dependent case, but because we use another variable, okay, d, to deal with it. So this is the way we get around the the issue on dependence. So because they are dependent and it is difficult to deal with them, so we use the variable d, okay? And what is d? d is xi minus yi, okay? So in this case, we are able to deal with it with a new variable. And of course, the final point is, what is the interval estimation for this? So really we are interested in, okay, mu x minus mu y, right? And what is this? This is really mu d, right? This is mu d. And so we use d bar to estimate mu d. Okay, we use d bar to estimate mu d. And generally in this case we assume, okay, we assume the sigma d squared is unknown. Okay, we assume that is unknown, so we have to use t distribution, right? And what should be the, okay, what should be the degrees of freedom here? N minus 1. Remember, we already have a new variable, that's d. And how many samples we have? We have n. And so the degrees of freedom, n minus 1. And here, what is that? Going to be n, okay. This will be sd squared, okay. So basically, even though, generally speaking, when the two populations are not independent, we have to get through a more complicated processes. But in this case, we get around with it by using a new variable, okay, that's d. And so basically that's the same thing, right? Basically that's the same thing as one variable. Okay? Any more questions? Of course, if this is known, okay, suppose this is known, what should be the distribution? What kind of distribution will we use? We will use z, right? Or if the sigma d squared is known, then we use z distribution. Okay, any questions so far? Okay, the same thing, let us get to population proportion. Questions? Okay, when we say we are trying to deal with the interval estimation for population proportion, for the cases we talk about, we say we are trying to estimate mu x, right? And of course we use x bar to estimate it. But in this case, we are trying to estimate what? We are trying to estimate p. Okay, p is a proportion, say this is 0.3, 30%, 0.5, 50%, whatever it is. Okay? So when we try to estimate mu x, we use x bar, and we use what kind of distribution? Z distribution, right? If it is z distribution, then it's this case. If it is t distribution, okay, that would be t n minus 1, right? Okay? But now, what kind of distribution we are dealing with? We are dealing with p, okay? So then you have to figure out what is the mean, okay, for p. The mean for p is exactly p, right? And what is the standard, the variance? The variance is pq over n, right? So when we have x, there will be mu x sigma x squared. When we have x bar, there will be mu x and sigma squared over n, right? So when it is a Bernoulli, okay, then we have P and PQ, right? And when we have simple sum, okay, for the proportion, there will be MP, okay, MPQ. When we have simple mean for the proportion, what do we have? We have P and PQ over N. So the difference is here, okay? The only difference is here. So then to estimate the population proportion, okay, what are the formulas? So in this case, let us say the true population proportion is P, and the sample population proportion is P prime, okay? So let us use P prime. So for the mu x, there will be x bar plus minus z alpha over 2 times this. Then for P, okay, then we say P prime. P prime is the sample population sample proportion, okay, sample proportion, plus minus z alpha over 2 and PQ over N. So basically, the formula is the same, okay? The difference is because we are dealing with proportion, so the variance is different, okay? The variance is different. But basically, all the other things, they are the same. Of course, we can say P1 prime, okay? So let us say we have two populations, right? The first population, P1, the second population, P2, and now we are trying to figure out the difference between these two populations. And suppose they are independent, so what do you have? You're going to have P1 prime minus P2 prime plus minus, okay, Z alpha over 2, and what do you have? Because the same thing, right? The sample size for the first sample and the second sample may not be the same, right? They don't need to be the same. So we say N1, okay, then this P1, Q1 plus P2, Q2, and this is N2. What does this mean? In this case, we mean these two populations, they are independent, okay, they are independent. So in terms of the population proportion, the interval estimation is basically the same as what we talked about before. But of course, now we are dealing with proportion. So the variance is different now. Okay, the variance is different now, but generally everything else, the theory and the process to derive this confidence interval, it is the same. Okay? Any questions? Okay, let us move on. Now we are trying to deal with the confidence interval estimation for variance. Okay, so now we are trying to deal with the confidence interval for variance. And we know variance is equal to sigma x squared. And also we know to deal with sigma x squared, okay, what is an unbiased estimator? The unbiased estimator for this is Sx squared. We use this one to deal with that one, okay? But now the question is, what kind of distribution we are looking for? Okay? The first hour we discussed this. We say n minus 1 Sx squared divided by sigma x squared is chi-square distribution minus 1, right? So because of this, we are trying to figure out, of course, the information we want to know is sigma x squared, right? But this is generally an unknown number. So we are using this, the sample variance, to figure out what's going on in terms of the population variance. So in this case, how to deal with it? Of course, when we talk about confidence interval, we have confidence level, right? So we have to figure out the confidence level and from there to move forward. Of course, we already know this is a chi-square distribution. So this gives us some hint. There's something we can do from here, okay? Okay, so we have P, and the confidence level is equal to 1 minus alpha, okay? And let us say this is n minus 1, okay? And here it is alpha, alpha over 2, right? And then this is chi-square distribution, n minus 1, 1 minus alpha over 2. And this is chi-square, okay? Of course, it is n minus 1 degrees of freedom. Just like we say Pz less than or equal to z alpha over 2 greater than or equal to negative z alpha over 2, that is equal to 1 minus alpha, right? That's the same thing. Or basically, they are the same thing. Now, we just plug in the formula here. What is the formula? The formula is there, right? So this variable, as a matter of fact, is equal to that one. Okay? So we say this one okay? Any questions? Now we want to flip around, so we get a reciprocal, okay? Reciprocal. So we want to flip around. So originally we say 3 less than equal to 4 less than equal to 5, right? But we want to flip around, so turn it upside down. So then it is 1/3, right? But 1/3 will be greater than or equal to 1/4, greater than or equal to 1/5, right? So what happens? You have P, okay, chi-square n minus 1, 1 minus alpha over 2, greater than or equal to, right? Sigma x square and n minus 1 sx square greater than or equal to 1 over chi-square n minus 1 alpha over 2. Any questions? We just flip around, okay? Turn it upside down, okay? We get a reciprocal for this, and another reciprocal there. You want to check this word, okay? Reciprocal, okay, reciprocal. Okay, any questions? Because we are not used to this kind of writing, generally we use less than or equal to the smaller number first and then the higher number. So let us rearrange this formula, this equation. So we have P, okay, 1 over chi-square m minus 1, okay, alpha over 2, less than or equal to sigma x square m minus 1 sx square, less than or equal to okay, any questions? Okay, so now this is what we have, right? This is sigma x squared. So let us multiply the whole thing with n minus 1 times xx squared. So what we get? We will get P and n minus 1 sx squared chi-square n minus 1 alpha over 2 less than or equal to sigma x squared less than or equal to n minus 1 xx squared and chi-square n minus 1 minus alpha over 2. Okay, so this is what we get. This and this is the confidence interval for sigma x squared. So when we have mu, right, and we try to estimate mu, we have x bar plus minus, okay, z alpha over 2 times sigma x squared divided by n. Okay, that's for mu x. But what about for sigma x squared? It is between this number and between this number. Okay? So that would be and this number, right? So you want to be very careful because this is 1 minus alpha over 2, right? And this is alpha over 2. So you want to be very careful about this, okay? Don't get mistake here. When in the final, I may have this kind of question, but as you know, I don't want to bother printing too many tables for you. So in that case, you don't have to calculate it, okay? But you have to put down the exact formula in this case, okay? You have to put down the exact formula. You don't have to give me the number, but you have to get to what it should be. So you have to give me the degrees of freedom and the proportion here, okay? The proportion, the probability here. Okay. Any questions? Okay, let us talk about some of the relationship between chi-square distribution, t-distribution. For t-distribution, okay, when the degrees of freedom is v, okay, then if v approaches infinity, then tv approaches standard normal, okay? And in this case, we say z squared, okay, is chi-square with degrees of freedom 1, right? So what does that mean? That means t, if the degrees of freedom is infinity, then also that is chi-square with degrees of freedom 1. And in this case, you know, t distribution with degrees of freedom n minus 1 is equal to z, right, standard normal, divided by chi-square distribution m minus 1 degrees of freedom and divided by m minus 1. So in this case, you may find out there's some interesting things going on here, okay? First, t distribution with degrees of freedom v, when v approaches infinity, what you get? You get tv will approach z distribution, right? Okay? So what does that mean? That means if n is very large, right? If n is very large, it will be equal to z distribution, right? Okay, so now my question is, what happened to limit n approaches infinity, m minus 1 chi-square m minus 1? What will be this equal to? Because you know, t with degrees of freedom n minus 1, right? And here you have chi-square distribution with n minus 1 degrees of freedom divided by n minus 1, okay? When n is approaching infinity, you get z, right? So what happened to this part? How much should that be here? It should be equal to, that should be equal to 1, right? That should be equal to 1. So when we talk about F distribution, okay, you will know more, you will learn more about the relationship between T, Z, and F, okay? So we got some minutes left, so let us talk about F distribution. F distribution, it has 2 degrees of freedom, V1 and V2. So what is F distribution? It is chi-square V1 divided by degrees of freedom V1 and chi-square degrees of freedom V2, okay, divided by V2, okay? So F distribution, the formula for this is this. So then, in this case, you can see F V1 V2 is equal to what? 1 divided by F V2 V1, right? Because in this case, okay, because in this case, what do you get? You get V1 V2, right? And here V2 V1. V1 V2. If it is the reciprocal of this, right? What does that mean? You turn it upside down, right? Upside, downside up, upside down, right? So in this case, what you get? You get exactly the formula here, okay? So you have, for F distribution, there is a property for this, okay? There's a property for this.